All right, so this is problem 3 of the video quiz, and this is the logo, the last one, best one. So Mr. Spencer's statistics class noticed that Mr. Spencer appeared grumpier and more tired than usual, and that he was assigning copious amounts of statistics homework. The students know that Mr. Spencer enjoys a can of Happy Juice every day. The Happy Juice distributor claims that each Happy Juice container contains 12 ounces of the delicious Happy Juice. Spencer students collected a random sample of Happy Juice. Hey, that's great. And weighed the amount of Happy Juice to determine whether or not the distributor was putting less than 12 ounces in each container. Assume that the population is normally distributed. Construct a 95% interval and explain the meaning of the confidence level. So you need to take a moment and enter that data into the calculator. I put it in the stat edit, and then once I entered it in the stat edit, I went to stat calc, one variable statistics, and I'm just doing this so you can check your work. And I ended up getting, and I hope I did this right, an X bar of 11.905. I got an S of 0.1848, and my sample was their sample was size 20. All right, so you might want to do that to check yourself out before you get going on this, make any data entry adjustments. So the very first thing in the recipe was define the parameter in context. And so it's really important in this one because we're talking about Happy Juice. So let mu equal the true population mean amount. And it's not just juice, but it's of Happy Juice. So we need to make sure that we have happy in there because we need to make sure that you keep them happy. So let mu equals that. Write the conditions. The first condition is random sample. The students were very smart, took a random sample. So that's a given. Obviously, Mrs. Lamb and myself have done a good job training you in the importance of random sample. N needs to be less than 20% of the population, 10% of the population. So we have 20 cans divided by 0.1 equals 200. Reasonable to assume that there are more than 200 cans of Happy Juice. I can confirm that to be factually accurate. So the sample is less than 10% of the population. And remember, we're doing this is kind of a test for independence. What I mean by that is with the giant pile of M&Ms, we take an M&M out and the percentages change, but they change so slightly we don't worry about it. Well, so the question is, how much can we take away without it not being an impact? We just randomly choose 10%. There are other rules of thumb, but that's the one we use. The next condition is the normality condition, and they gave us data, so we go, oh gosh, I have to input it. But they were really nice to us. They said the population is normally distributed. So the population is normal. How do we know that? It was given. Take a deep breath, smile, and be happy. All right, maybe you got a little bit of Happy Juice today. I don't know. The next thing says write the equation. Our equation is going to be X bar plus or minus T star S divided by the root of N. It also says we need a graph and shade. Well, we're supposed to be constructing a 95% confidence interval. So this means this is 0.95. By the way, that means I have an alpha level of 0.05. because the area in the tails happens to be 0.05. Some of you go, well, the area in this tail is 0.025. That's correct. And so is this area. And so together they sum together to give 0.05 because alpha is just the area in the tail, regardless of whether it's in one tail or two tails. So we're going to be looking for this lower and this upper value. All right, we're looking for a lower and an upper value. And at this point, we can start plugging in. Well, we already calculated our X bar, and we calculated 11.905 plus or minus. We haven't done T star, and I'm going to come back to T star in just a moment. S is 0.1848, and N happens, and so we're putting the root of 20 in here. And by the way, our degrees of freedom, I should have done this already, degrees of freedom, since we're working with a T, is 19. So here we go. Second vars, inverse T, which happens to be number 4. The area, because we're doing a confidence interval, is going to be parenthesis 1 minus 0.95, and we're going to divide that by 2, and our degrees of freedom are 19, or just the 20 minus 1. And I end up getting a T statistic of 2.093. All right, now that we've done this, we can go ahead and run this thing and get our actual interval. So stat, test, and we're going to drop down to number 8, which is our T interval. And we have our data list. It's in L1, and we're going to do a confidence level of 0.90, or 90%. And we end up getting an interval of 11.834 and 11.976. Wow. So stat, test, T interval. Oh, I'm sorry, I ran the wrong one. I should have run a 95%. T interval. Oops, that's wrong. Change that to 0.95. And I end up getting 11.818, 11.992. Pause this for just a second. I apologize, but I'm going to run that one more time. So stat test number 8, which is a T interval. My data is in L1. My confidence level is 0.95. And I end up getting 11.818 and 11.992. So this is my lower bound, and this is my upper bound. So what can we say? We're going to write our conclusion, and we are 95% confident that the true population mean ounces of happy juice lies within the interval 11.818 and 11.992. So we are 95% confident that the true population mean ounces, or mean number of ounces of happy juice, lies within the interval 11.818 and 11.992. It also says explain the meaning of the confidence level. All right, so we have to explain the meaning of the confidence level. So this was number 11. We did, and we always have to do number 11. That's not, we never don't get to do that. Here we have to do the confidence level, and that's where we get to talk about how good our design is. So in repeated sampling, we expect that our method will capture the true population mean number of ounces or happy juice ounces 95% of the time. In other words, if we did this an infinite number of times, 95% of the time it would work, 5% of the time it would be wrong, it wouldn't capture it. And so we just say if we did it over and over again, about 95% of the time it's going to capture the true population mean number of happy juices. Part B, does this interval indicate that Mr. Spencer is being deprived of his happy juice? And the answer is yes. 12 ounces is not in the interval. The interval lies below 12 ounces. So we are 95% confident that the average number of ounces is less than 12. All right. So you need to worry, Mr. Spencer is being deprived his happy juice, and that's going to be a bad thing. All right. Could be a really bad thing for all of you. Part C, and I have a typo. Would you reach the same conclusion if you were constructing a 99% confidence interval? Well, first off, we've already defined the parameter. We've already written the conditions, so we don't need to redo that. Let's go ahead and just do our formula and our graph. So x bar plus or minus t star s divided by the root of n. Our graph is going to look like this. Instead of having 0.95 in the middle, we have 0.99. And this gives us an alpha of 0.01. And technically, the area in this tail is 0.005. The area in this tail is 0.005. We need a lower bound and an upper bound. We start plugging in, and we're plugging in from what we've previously done. And so our x bar from previous was 11.905. Plus or minus, we'll have to get a new t star because we changed our confidence level to 0.99. S, in this case, is still 0.1848. And our square root of 20. T star, second vars. And you have to do this. Unfortunately, they don't give you this on when you actually run the test. So you have to go ahead and show this value. And we end up getting 2.8609. All right, so 2.8609. Now we can go ahead and run the test. Stat test number 8, which is a t interval. And I need to change my confidence level to 0.99. And in this case, we get 11.787 and all the way up to 12.023. And guess what? Our interval contains 12. We cannot say with 99% confidence that the distributor is underfilling. I guess Mr. Spencer is just being grumpy. All right. Now notice that that was different than what we came up with at the 95% confidence level. Why? The reason why was our T-star changed. It was 2.09 when we were doing the 95%, and when we were doing the 99% is 2.86, which means our margin of error got wider. This interval at 99 is wider than the interval at 95. And the very last thing, correctly identify Mr. Spencer's happy juice. And in case you don't know, Coca-Cola. Those in my class who actually see it in class know that I keep a stash of Coca-Cola in my classroom. All right, hopefully this will help you all prepare for your tests. This is good study material. Anyway, thank you.